Hi all. So today we are going to solve another problem which is unique binary search trees. Leetcode number 96. So this is a medium problem. Let's go through the description of the problem first. It says given an integer n, return the number of structurally unique BSTs which has exactly n nodes of unique values from 1 to n. So they have given one example for n3. It's 1 and I will go through the definition of BST in some time, but let's just look into the input and the output. So they are saying when the input is n, output should be 5, and when the input is 1, output should be 1. Correct. Now let's go ahead and see what is binary search tree, right? So we do say one tree as binary search tree if whatever value I have here n, my left child should have the value less than n and my right side can have value greater than or equal to n, right? What does that mean? So this means if I have 2 as my head node, my left node can't contain 3, right? It should contain less than equal to 2 any value. That means 1 or 0, right? And my right node can't contain 1. It can contain 2 or 3, right? So this is the basic definition of binary search tree. And as the name suggests, binary, right? So that means it can have only two children, one is left and one is right. It can't have more than two. It can have at most two children, right? It can have 0, 1 or 2 hands with it, right? Now let's go ahead and take the first example where we have n equal to 3. Let's just assume we have one example where we have 3 nodes as 1, 2 and 3, right? So let's see what all trees we can create using these 3 numbers, right? If I have 1 in my head node, in my left node, can anything contain which is less than 1? We don't have any node, right, which can be less than 1. So all my 2 and 3 will come in right hand side of 1, right? So how can it come? It can be like 2, right, and then 3 here. So can 3 sit here? No, right? So 3 also can only sit here. This is one of the possibility, right? So you got it, like how we are constructing it. So 1 being my head node, left side nothing is there, that means nothing can sit on my left hand, but right hand it can be 2 or 3, right? What can be the next possibility? 1, if I have 3 here, right? 3, so in right hand side it can be 2 or 3, right? So if I have 3 here, left can't sit in this hand, right? So 2 can only sit in left hand like this, correct? Now let's take example when my number 2 will be sitting in head. So for 2, let's just erase this so that it will be easier to understand. Okay, so if I have 2, right, now 2 is the head node, so the left hand side of 2 can contain this 1, right? So left hand side can contain this 1. Now coming to this part 3, so 3 can be sitting in 3 right side, right? Can there be any other possibility from this? No, right? Because left hand side is containing only one value as well as right hand side. Now let's see what will happen if 3 sits at head node. So in left hand side I can have 1 and 2, right? We will come into this later, how can we break it down. And right hand side will not contain anything, right? So let's just see what can we do here, like 1 2, right? Let me just erase 1 2 from here. So what all possibilities we do have, right? We can have 1 here, and 2 can't sit in left side, left hand of 1, right? It can only sit in right hand. So this can be one of the possibility. Another one can be 3 1, sorry 2, and then 1 can sit at right hand side. See, the number of possibilities 1 has and the number of possibilities 3 has are same, right? Because 1 didn't have anyone to sit on left hand, similarly 3 didn't have anyone to sit on 3's right hand, right? So basically we saw if we have only one node like 1, how many possibilities we have? We have only one possibility, right? If we have two nodes, how many possibilities we have? Suppose we have only 1 2, these values, how many possibilities we will be having? Let's see. So what we do, we keep the head node 1 here. Where can 2 sit in that case? 2 can sit only in right hand side, right? Similarly, if we put 2 in head, then who can sit in left hand side? It's only 1. Right hand side, no one, right? So if we have two values, then we can have only two nodes to form a BST, unique BST, right? Okay, now let's go into the code part of it. So what are we basically trying to do here? Like we are saying, if we have a value, if we have one value, then 1, and what about 0? Like if I don't have anything in that list, if n is 0, then also I can create only one tree, right? And since this is a combination, right, like it's a unique combination, so if I can, so my total value will be how many am I able to create from left side and how many am I really able to create from right hand side, a multiplication of that, right? So if I say this function name is numTrees, so what can I do? I can split the whole list into two part, whatever I am picking up as head node, then I have to see how many are there in left hand side, how many are present in right hand side, and just do a multiplication of that, right? The combination, like the total combination, correct? So can we say our function, it's like something like this. Can I say number of trees of 0 is 1, like this is my base situation, right? And I can also tell number of trees is 1, like whenever my n is 1, then I can have one tree, right? Similarly, let's now go into this problem, like when n is 2. So when n is 2, what are we basically trying to do? So one possibility is I am taking, so when my n is 2, right, if this is my head node, do I have anything in left side? No, right? So that means 1, if I break it down in two parts, then this will have nothing, null, so 0 nodes, right? And how many my right nodes will be having? 1, right? This is one combination. Another will be if I keep 2 as head node, then my left hand side will be having 1, but right hand side will be having 0 nodes, right? So, and we need a total combination, correct? So can we say, like if I have n equal to 2, then this is the total number of combination we will get for unique BSTs? Now let's see what will it look like when I have n equal to 3. If we see these 3 examples, I think it will be very much clear to us what exactly are we trying to do. So if I have number 3, right, if I have n equal to 3, what can happen? Okay, let me just clear out this whole page. I'll just redraw. So if I have 1, 2 and 3 and I am selecting suppose the first element, right, for the first time. So if I want to create using the first element, see what can I put in left side? Nothing, right? So again the 0. Right side, how many element I am going to put? 2, right? This is one of them, and again in 1, 2, 3, if I select 2 as my head node, then left can have 1, right can have 3, right? Again if I have 1, 2, 3 here and I am choosing 3 as my head node, my left can have 1, 2, right should have 0, like nothing, correct? So let's see what our equation is saying. It's like when you are selecting the very first index, then your left hand side has 0 elements and right hand side has 2 elements, right? Easy way to remember this formula is, see the value inside this square brackets, like basically how many elements you have in total, that is n minus 1. So the total will always be n minus 1, because that extra one element is now my head node, which I am not taking into consideration because that is fixed for this particular combination, right? And if I split it in, like, in which case this is the one in my middle scenario, right, when I am exactly splitting my array from middle, right, that time my left will have one element, right will also have one element, correct? And when I am splitting it at very last element, that time my left hand side will be having two elements and right hand side has zero element, this case, right? Cool. Now let's just start coding. I hope this is clear. So I am following one variable where I will be keeping result, like this is something I will be returning as 0. And if you guys have seen one scenario, it's like 3, although it has, we are picking up the last element, right, but how many trees are possible by using only two values, that is always fixed, right? 2. Whatever example you take, like instead of 1, 2, 3, if it is 3, 4, 5 also, you will get 5, you will get 5 trees only, right? Why? Because the condition is fixed, like always your left should have less and your right should have more elements, correct? So this is the result which we are going to return at last of our code, right? Now num trees, so I am going to follow one array because I don't want to re-evaluate this nums 1, right? As you can see, this num trees 2 is getting used 2 times. So we don't want to calculate it every time, right? So what we are going to do, as soon as I calculate this part, I will be storing it in an array. So next time when I need the value for 2, I will be getting that value. So this is a very simple program of dynamic programming where you are reutilizing the value you have calculated, right? So if I have result equal to 0, now I am going to use one map here where I will be storing the values I have shown in the previous example, right? So as we have seen, right, that our 0th and first index will contain, like if the value of n is 1 or 0, the result will be 1. So I am just initializing this map. This is not a map as such because we know like each index will be having the same result, so we can just write it like a num trees result, right? So this this is the one where we will be tracking our results, like what is the result for 0, what is the result for 1, what is the result for 2, right? So this is where we are going to store. So this is where how we are going to use the dynamic programming. Now let's just see how our for loop will look like. I think you already got how am I going to solve the problem. So what we need, right? What is our what is ultimately we want? We want this value, right? If my n is 3, I want the result from num trees result 3, correct? So how can we achieve that, right? In order to calculate this 3 value, just see what all values we need. We need 0, 2, 1, right? So and ultimately we need n as well, correct? So our first loop will start from 2 and it will go till n plus 1, right? So why so, right? Because for 0 and 1 we already know the value, so we don't need to calculate anything here. Calculation will start from here, correct? And you see, like inside for this 2 as well, we need one loop to calculate this thing, right? Once I will start, you will understand what I meant. So I am just keeping one local variable total 0 to calculate just this part, right? Nums 2, like what is the value for my node, right? Now this loop I will just explain in a bit. If subnode in range nodes, right? Yeah, now see here what loop I need. I need 2 loops for n equal to 2. I need 3 loops for n equal to 3. And what is my left looking like? My left is increasing by 1, like 0, 1, like that, right? Because when I'm splitting it, left is basically when you are splitting by one index, what is the value? Like when you are splitting by one index, what is the value? How many elements you have in left, how many elements you have in right? So in our case, when we are splitting by first index, in left we have nothing, in right we have 2 values, right? Like this. So our loop will start from 0, it will go till n minus 1. As I told you about the logic, why we have the total sum of n minus 1, because that one extra is my head node, right? And let's see what will be my left node. So my left node will always be the sub node we have just done here, right? So it will be 0, 1, 2, like that. In case it is n is 3, this will be 0, 1, 2, like that, correct? And my right node will be total number of nodes, which is in case of 3, total number of nodes will be 3 minus the subnode minus 1. So this minus 1 is for my head node, because I already have head node which is fixed. I don't want that value in my right side, right? And now what will be my total? So as we have seen, our total is this one, and again in the second loop plus this one, right? So my total will be what I have in my left value plus what I have in my right value, right? So the first loop is to create this whole tree, and the second loop is to create the sub solution of that problem, right? So this is my right. So after calculating the whole total, what we are going to do is, in my result for this particular n, I am going to store whatever my total value is, right? Okay, now after this one, I do have value for num 0, 1, 2, 3, right? Now what I have to return? I have to just return the last index value, right? They didn't ask for what is the value for 0, 1, 2, 3, right? They wanted the result for just n equal to 3. So I will return this n value. So basically we don't need this result, because we already have this stored in result array, and that is what I am going to return. Now let's just run and see what we are getting here. Okay, so we got somewhere wrong. Let's see what we have done wrong. Okay, total is assigning as 0, and then we have a left node, we have right node. Okay, this won't be plus, right? It is like a combination, as I told. So it will be the whole combination from here multiplied by the combination we are getting from here, right? Because this is not a total sum, right? This is a combination problem. So let's see. Okay, test case passed. Let's see the actual result. Okay, this also passed. Okay, I got it. Like this answer came correct, and this is not bad. Let me know in comment section if you get any other optimized solution, then we can discuss about that as well. Till then, keep watching.